Welcome to another day at camp. I hope you guys are having fun. I am going to be reading today Floods of the Past and Future by Karen Donnelly. Chapter 1 Floods. In December 1999, along the coast of northern Venezuela, more than 36 inches of rain fell in 72 hours. This amount is equal to the average yearly rainfall for that area. Rivers overflowed their banks and sent water down hillsides. Mudslides crashed down the slopes of nearby Mount Avila and swept away about 12,000 homes. More than 20,000 people were killed. Many of them were buried alive or carried out to sea. Some scientists are concerned about deadly floods like this one and their link to our changing climate. They are especially concerned about changes in Earth's temperature. To better understand Earth's climate and temperature changes, we will learn about the water cycle, global warming, and the greenhouse effect. Chapter 2 The Water Cycle. The water cycle moves water from Earth to the atmosphere and back again. The sun warms water in oceans, lakes, and rivers. Some of the water evaporates or changes into a gas called water vapor. When the water vapor rises into the cooler air, it condenses, changing back into liquid water droplets. The droplets become too heavy to stay in the atmosphere and fall to Earth as precipitation. A change in Earth's temperature could affect the water cycle. If it gets warmer, evaporation will happen faster. More water vapor will rise into the atmosphere, and more precipitation will occur. More precipitation can cause flooding. Scientists who study the weather, or meteorologists, think that Earth is getting warmer. Chapter 3 Global Warming. In the last 10,000 years, Earth's average temperature has increased 1 degree Fahrenheit every 1,000 years. However, in the past 100 years, the average global temperature has already increased 1 degree Fahrenheit. The world's climate might change if this high rate increase continues. Warmer temperatures affect the water cycle. Changes in the water cycle may mean increased precipitation, which could lead to flooding. Human activity is connected to global warming. Since the Industrial Revolution, people have burned larger amounts of fossil fuels. We use gas and oil to power our cars and to heat our homes. This sends carbon dioxide into the air. Understanding how carbon dioxide absorbs heat and helps keep Earth warm will help us to learn about Earth's climate. Chapter 4 The Greenhouse Effect. Carbon dioxide and other greenhouse gases found in the atmosphere help to warm Earth. This process is called the greenhouse effect. Like the glass walls of the greenhouse, carbon dioxide traps heat from the sun. This makes Earth warm enough for plants and animals. Plants are very important in regulating the greenhouse effect. Plants use carbon dioxide to make food during a process called photosynthesis. This process keeps carbon dioxide levels balanced. Earth's temperature is affected when humans change the natural environment. When people cut down acres of rainforest, a process called deforestation, the amount of carbon dioxide in the atmosphere is increased. The greenhouse effect increases, and Earth's temperature rises. Chapter 5, Humans and Flooding. In the natural environment, rain soaks into the ground. Wetlands, the low-lying areas near rivers and lakes, provide space for high water to spread out. When we change our environment, this natural system of flood prevention does not happen. The ground is covered with streets, parking lots, and buildings. This is called urbanization. Instead of soaking into the ground, rainwater is trapped by asphalt and constrict. Runoff caused by heavy rains can turn streets into rivers. Scientists believe that urbanization and deforestation affect Earth's climate. Human activity could lead to increased global warming. This means more precipitation, which could cause flooding. Let's learn more about how floods happen and why they are dangerous. Chapter 6, Flash Floods and Ice Jam Floods. All floods are caused by too much water collecting in a short time. During a flash flood, water with a very strong current rises quickly. Rushing floodwaters can cause water to move downstream too fast for people to escape. This results in many deaths. In 1972, a flash flood in Rapid City, South Dakota, caused by 15 inches of rain in 5 hours, killed 237 people. In early spring, ice that covers the river begins to melt and to break. Large blocks of ice break apart, float downstream, and can pile up against bridges or shallow areas. An ice jam forms, causing water to back up and to press against the ice blocks. This water may flood over the riverbank. If the water pressure causes the ice dam to break, a dangerous flash flood can occur. Chapter 7, Storm Surge and Dam Failure Floods. Storm surge floods are usually caused by hurricanes. Water is pushed from the ocean onto land. Walls of water more than 20 feet deep may crash against houses built along the beach. Pounding waves create very dangerous flood currents. In 1900, a hurricane storm surge in Galveston, Texas, killed more than 6,000 people. Where rivers flow past cities, we build dams and levees to control water. The levees keep river water out of cities, even when the water level rises. Sometimes, though, a dam or a levee breaks. Then all the water held behind it crashes downstream. On May 31, 1889, following days of heavy rain, the South Fork Dam broke in Johnstown, Pennsylvania. It sent 20 million tons of water rushing into town. More than 2,200 people died. Chapter 8, Regional Floods. Regional floods usually occur when winter rains or spring rains combine with melting snow to fill rivers with too much water too quickly. The ground may still be frozen, which keeps water from soaking into the soil. Other times, long periods of extended rain cause the ground to become saturated. So much water has already soaked into the soil that no more can be absorbed. The extra water runs into rivers and streams, bringing them to flood level. Levees may help keep rivers from flooding cities, but they can also add to regional flooding problems. The cities that have levees are safe from rising waters. Downstream, where there are no levees, this extra water spreads. Small towns and farms without levees experience severe flooding. Chapter 9, fertilizing with floods. Floods cause disasters, but they can also be helpful. When a river flows downstream, it carries silt. Silt is made up of very small pieces of clay, dirt, and other materials. Whenever a river overflows its banks, it dumps the minerals found in the silt on the surrounding land. After the floodwaters recede, the minerals help to fertilize the soil. The ancient Egyptians knew that floods help farmers. They planned their planting seasons around the annual flooding of the Nile River. They called the flooding the gift of the Nile, because the river brought natural fertilizers. The earlier the flood, the better the year's harvest would be. The same is true today. Some of the richest farmland in the United States is found in the Mississippi River Valley. Chapter 10, Future Flood Watch. Global warming may affect the water cycle. This effect may increase precipitation. Scientists carefully study this connection to help predict flooding. Regional floods are often easier to predict than are flash floods. Warmer temperatures in early spring cause snow to melt quickly. When heavy rains also occur, scientists know flooding is likely. People along the river have time to prepare. On the other hand, flash floods are hard to predict because they happen so suddenly. We will see whether Earth's average temperature continues to rise. Scientists are keeping a close eye on the greenhouse effect and the effects of other human activities. Some are concerned that higher temperatures could cause more heavy rainstorms and dangerous flooding. The end.